Hey everyone, it's Pete from Ironclad and welcome to part 2 of Touchscreen. Well, it's kind of amazing to find out just what is conductive when you're looking at conductive materials. Yep, your nose is conductive. How about that? Anyway, let's get right into the details about touchscreen gloves, what makes them conductive, and why our command series are just so great. So what I want to talk about today is the conductivity within gloves, because we have conductivity in our hands and our nose, as you saw. It's naturally occurring, a carbon element that draws the electrical current through. But we don't have that in normal fabrics. Obviously we have it in steel and water and things like that, but we don't have it necessarily in fabrics. So there's really 4 types of fabric/glove treatment that have been used for conductivity to help us with touchscreen devices. So the first type of glove is where they do a conductive surface treatment. And what they really do is they treat one layer of fabric, a very thin layer of conductive fabric, and they bond it or stick it or adhere it to another fabric, your base fabric that you're working with on your glove, and it forms like a film, a flexible fabric film over the top. Now that's kind of good and it allows flexibility, but it wears out. They wear out very thin because it's just a layer on top, and usually it's only put in certain parts of the fabric. So it does wear out very thin, and also that fabric doesn't work particularly well in cold and wet conditions. So it has its limitations. So the second method they use is a conductive patch that's usually sewn in only to one area, usually on your fingertips, and they use like a metal thread that can be woven into the thread, but because they don't want to put that on the whole glove, they usually just put it on a patch, like on a fingertip, and then they put that patch on the fingertip, or they weave it in, or sometimes they even just put it in the stitching. Now that can be quite durable, but there are some real cons against it. It can be uncomfortable. It can have limited touchscreen coverage because, you know, sometimes it doesn't get on the top of the finger or on the side of the finger, or, you know, you're missing it, or you've got to hold your finger at funny angles and it doesn't kind of work. Usually you have to have exposed seams because of that type of thing. And generally there's relatively poor functionality in cold weather and dry weather and wet weather because the conductivity gets a bit confused. It just doesn't seem to work as well. So there's some pros and some cons. The third and final solution before we get into our gloves is really a type of tool. So a stylus or a pen that is made to use with touchscreen, and usually they have special tips on them. Some have very, rubberized tips, some of them have metallic tips, some even have little press-in tips. They can be very good. They give you very high precision on touchscreens, but there's a couple of really big downsides to them. A, you can lose them so easily. Imagine being out on site somewhere in remote application, you lose your pen, and that's all that works with that particular device. The other thing is they're obviously not integrated with every sort of solution. So they work on some, they don't work on others, and so you have some real problems with that. They can be fantastic, they can be longevity, but they're not an overall great solution, particularly for work sites and remote sites and, oil and gas, construction, mining, roadworks, all that type of thing. You lose those. Courier drivers, in factories and manufacturing, you lose the pen, you lose the ability for the touchscreen. The fourth and final solution we come to is the Ironclad solution. It's our command series technology that we've incorporated into our new touchscreen fabric. And that fabric is just amazing because what we've done is we've introduced carbon-based nanoparticles into the actual woven thread itself. So when the fabric is made, it's all touchscreen. The whole palm is touchscreen. So in this instance, all of that fabric is actually touchscreen because it's infused into all of the fabric before we even put the glove together. It's not a coating, it's not a touch, it's not a pen, it's in the fabric itself. Now, what's so important about that? Well, firstly, it doesn't wear out. Let me show you a really simple real-world test of electrical conductivity. Now, our R&D department's got all sorts of devices to measure how conductive something is, and I can give you the data on that, but here's my finger, here's a plasma ball, and it's conductive. It's drawing the electrical current into my finger, and I'm creating a circuit, thereby it's conductive. Here's my glove, plasma ball, and it's drawing a current in through the glove, through those carbon nanoparticles, and it's conductive. That's why I can tell you our touchscreen gloves are conductive. They are really, really great. And look, there's my whole palm. It's all conductive. Okay, that's conductivity. So there you go. Touchscreen, part 2, conductivity, done. I hope that provides you with some good information on why our gloves are so good at touchscreen and why we regard them so highly. I would love to get more information to you about this, and if you want to hear more and read more, we have a fantastic little Glovepedia brochure here, and I'd love to get that in your hands. We can send that out to you digitally, or I can come and visit you, maybe, if COVID lets us, and maybe, but we'd love to. So please get in touch with us. Ironclad.com, brightonbest.com. Drop a comment below, send us an email. We'd love to talk to you about our touchscreen gloves. Hey, thanks very much for watching, and I forgot, please subscribe. If you subscribe, you'll get the next videos straight away, and I'd really love it. That'd be cool. Okay, I'll stop talking now. Great to see you. Thanks so much for watching, and I look forward to catching up with you next time. Bye.